Alright guys, so I'll upload these notes again just like I did last time. So I guess let's get going. Vertex form, I kind of already introduced it to you, so this is nothing new. It's just we're going to get more into detail with it. I'm going to show you guys how to find, I'm going to see if I can show you guys how to find zeros or roots or whatever you guys want to call them. Okay, but before we get started with that, let's go back to what we already know. First of all, what is vertex form? The form of a vertex. It's very deep, dude. What is vertex form, guys?
Vertex form is fx equals a parentheses x minus h parentheses 2 plus a.
Now, every part of this equation means something. Okay, every part of this equation has something that's going to help us out. I guess the most important part to this are your vertex. How do I get my vertex from this?
We do the parentheses other okay, opposite of h and k.
H and K, very good. And I guess let me call this vertex form, not just vertex. Okay, so vertex is H and K. How do I know the concavity of this?
The a. If it's negative, it's going down. Positive is going over.
Concavity. So if A is greater than 0, it opens what?
It goes on.
It goes up. If A is less than 0, it goes what?
Down.
It goes down. Right? How do I know my axis of symmetry?
From the vertex.
So axis of symmetry will be x equals what? Which variable do we use?
H.
X equals h. So far, so good? Okay. Now, I'm going to highlight some things on this vertex form. That's not a highlighter. Let's try that again. F of x and x. F of x and x are just points. They're just coordinates. And a lot of times, we take those for granted and we don't use them. Okay? Those are very, very powerful tools that we can use. You learn how to use those, you never have to go back to standard form if you don't want to. Okay? You can do everything from vertex form, but you need to learn how to use coordinates. Okay, you guys ready? Okay. So this is what I'm focusing on today. The other stuff you guys already know. This is what I'm focusing on today. Okay? So let's graph a couple. So let's get the stuff that we know out of the way. All right. I know you guys already know some of these things. So I guess let's go with our vertex. What would our vertex be, guys? +3, +1. So let's look at concavity. And you know what? Let's make this, do me a favor, make this a -4. Or else we're not going to have any roots. Okay, let's make that a -4. Let's look at concavity. What's going to determine concavity? And what is A? A is -4. So that means this is concave what? This is concave down. Okay. Axis of symmetry. But I don't just say 1, and it's not 1 actually.
3.
I don't just say 3. How do I write my axis of symmetry?
It's 1, 1, 0.
No, it's not a point. The axis of symmetry is a line. X equals 3. Notice that I'm missing my y-intercept. Y-intercept is when you're in standard form. Okay, you cannot get your y-intercept just by looking at it. You can do it, but there's some stuff you have to do. Okay? So let's graph this so far. So my first point I'm going to graph is my vertex. So I'm going to go over 3. 1, 2, 3, and up 1. And then I'm going to put some points here. So I know that this is 3. The next point over would be what? 4, 5, 6, 7, 2, 1. This is 0. This is -1, and so on, right? Okay. I know that this is concave what? Concave down. What I'm going to do right now is I'm going to draw my axis of symmetry. So that's x equals 3. Okay, so that's x equals 3. Now remember, today I wanted us to focus on points and how helpful they are. X and f of x. Let me go up here so I can try to make a point for you guys. Try to get the... I'm trying to show you guys so I can get it across. Is this already a point? Yeah.
Yes.
We already have one point, which is 31, right?
Yes.
And we know that this is symmetrical. That means whatever exists on this side also exists on that side, right? How can I find another point? Because vertex form only tells me that this is going to open down, and that's it, and the vertex. But I want to be accurate, yeah? Plug what in, though? That's what we need to get good at. We need to know what numbers to plug in. The numbers that are next to the what? The axis of what? Axis of symmetry. So if my axis of symmetry is 3, what would be a good coordinate to start with? 2. So I can plug in 2. I plug in 2 right here. Okay, so the first coordinate I'm going to plug in is 2 and f of 2. I want you to notice something. You already know your x coordinate. You don't need to solve for that. That's what you're choosing. What you have to solve for is for your y coordinate, your f of x. So it's going to be f of 2 is equal to what? We use our -4. And what do we plug in for x, guys? It's 2. Minus what? Plus k, which is 1, right? And now you can solve this. This is now solvable. So this is going to be -4. 2 minus 3 is -1 squared plus 1. -1 squared is +1. 1 times -4 is -4 plus 1. So that equals what? That equals -3. So look, I found a coordinate. So I know that my coordinate is when I go over 2, I have to go down to 3. So I found a point. I can go back to my graph, and I can go over 2 and down 3. But be smart about this, guys. Don't do more work than you have to. By finding 2, what else did I find?
4.
So I also found the point 4 comma what?
0.
Not 0.
-3.
4 comma -3. Does that make sense?
Yeah.
Okay, and now we're more accurate. I can even find another one, okay? So what would be the next point that you want to use here? 1 or 5? I'm going to go with 5. Okay, so I'm going to do the work right under it. So my next coordinate that I'm going to use is 5, and I'm trying to find f of 5. So it's going to be f of 5 is equal to -4. 5 minus 3. Okay, that's what I'm plugging in. That's what you chose. Now you can choose any numbers you want, but the further away you get from your axis of symmetry, the larger your numbers are going to get. So the closer you are, the easier your calculations are. 5 minus 3 is what? So it's going to be -4 times 2 squared plus 1. 2 squared is 4. negative 4 times 4 plus 1, and that's negative 16 plus 1, which is what? Negative 15. So we found the coordinate 5, negative 15, but by finding that, we also found what? 1, negative 15. So I'm not going to get accurate with this just because I don't want to go down 15 times. So I'll just put it right here, and I'll put this as, what is that, 115, 1, negative 15, and this one is 5, negative 15. Okay, and then you can draw your graph. Does that make sense, everybody? Yeah.
So I noticed that the problem that you're doing,
Uh-huh.
you can find the vertex, and then if you use the negative 4 and just make it over 1, it equals the same answer.
Yeah.
Why? Why does it do that?
If I was to use this 4 right here,
No. Can you just go back up to the original problem?
sure.
I'm gonna go up to the board at points.
I got you.
It's easier that way. Look. So, I've been solving all of the problems by finding the vertex with these two,
Okay.
and then plotting it,
Okay.
and then going down 4 and over 1. And it gives you the exact same. It's right here. It actually does it right here.
Yes.
You can get the first point doing that.
You could get the first point doing that, but the next point won't work that way. Think of this as part of it being a mixture between linear and exponential. Does that make sense? Okay. But yeah, that will work.
That's
That will
only
work.
the first
It's only the first point, yeah.
You just give me a cheat code. I know that.
Are we good with that one? Let's try that theory out. I'm gonna give you guys one with a fraction in it.
Oh, no. You see, you didn't have to do that.
You don't associate with that.
It's like a little bit of what we You may not do all that.
Go ahead, guys.
See, this is a little bit too much.
After this problem, how many guys prefer vertex or prefer standard form? Nobody prefers standard form? Vertex is better. I agree. Okay.
Little easy.
However, sometimes you may be asked to take a problem in vertex form and to put it into standard form. And that's what we're going to do next.
That's so ugly.
Actually, that is not bad. Going from vertex to standard is pretty simple. Going from standard to vertex, that's huh? Yeah, but I've been doing this for a long time. But it's a longer process. It's such a complicated, not complicated process, but it's such a specific process. It's got its own name to it. How many of you guys have heard of completing the square?
Oh,
no.
Oh, that's easy.
That's you use completing the square when you're going standard to vertex. So if you guys don't like graphing in standard form, then and you like graphing in vertex form, then you complete the square. You can put it in vertex form, and then it's easier.
And this is
Oh,
extra.
it's a lot of research.
Sometimes,
You got it? It did work, huh? Here.
So you can only find the first one, and then you have to enter in 3.
Sort of. Do you guys remember the mistake I did with the geometric when we were graphing our geometric? Right?
I know you made a mistake. I don't know.
You don't remember it? It was when there was a K in there.
Oh yeah.
Yeah. So I'll show you that. I'll show you that tomorrow. Okay. So I'll show you that trick. That you can use that trick again. I'll explain how it is. All right, let's go over this. You know what? I'm tired of writing. My hand hurts. Volunteer somebody for sacrifice. Who's gonna go? No, for extra credit. Who's gonna go? Who do you guys want to volunteer to write this?
Ralph wants to go. He had his hand up and he put it down. You're the smartest one in the room. Get up there and go.
No. You don't have to get up. You're gonna write it on here. Does anybody want to write it on here? All right, go for it, Ralph. Okay, here you go. Don't mess up, Ralph, because I'm gonna upload this to YouTube. No pressure, dude. Yeah, you're recording right now.
So what you gotta do?
Go for it, Ralph. Explain what you're doing, dude.
So look, drawing the okay.
Oh god.
You can put your hand on it, so you don't have to like. It won't pick up your hand. And if you want to erase, just turn the pencil around, so I can erase it. Turn it around, dude. Turn it around. There you go.
How do I draw a straight line?
You just asked how to draw a straight line.
Okay.
You gotta choose your color up there.
Wow.
That's great, Ralph.
He's nervous.
A little nervous, Ralph?
You gotta be. Keep it up.
Oh my god. Can't you make a straight line?
Be nice.
Why?
Don't you have like this thing where it's a
My knee pop.
Why don't you just use it?
My knee pop. Okay. You know? Ah.
I remember
Okay. -3. -3 plus 1.
That's the Vertex right there. -1.
Okay, Ralph. Slow down. Can you erase that for me? The side work?
What is next?
Wait, what?
Okay, quiet down, guys. Quiet down. So, Ralph, can you identify your vertex? Because I see it on your graph, and I'm pretty sure that you have it right. What's your vertex? Guys. Very good. The vertex is -1, -2. Now, Ralph, is this concave up or down?
Oh, you writing it?
Dude, just answer.
Very good. And how do we know it's concave up, dude?
Oh, you wanted to write it on there.
Say, use your words.
A is greater than 0. Very good. A is what, guys? In our case, A is what?
1/2.
A is 1/2, okay? So far so good. Ralph, great job. Let's put somebody else on this one. Beautiful. No, my bad. Let's go with, let's see. Let's go with Marisol. You got this. Here. You can put your hand on it. It's
So
okay.
serious. This is not gonna.
Okay, so
What am I supposed to do?
What's
So
my
you can
axis of
paint.
symmetry?
Huh?
The axis of symmetry, you know this. Come on.
No, I don't. What is it? Do I just write it?
Just draw it on the graph.
Like dot dot dot. Wait, this is scary. Like that.
All the way down.
I'm going. Jeez.
Good, so there's our axis of symmetry. Okay, can you draw our graph?
Oh,
Just to draw a general picture of it. We'll put in our points later, but just draw a general picture. We know that we have our vertex, we know it's concave up.
from his dots.
Uh-huh.
Okay. It's like an estimate.
Mm-hmm.
Okay. Okay. This is ugly. How do you
Why don't you do one swoop?
how do you do this? How do teachers do this? Like
I'll take over. That looks
Yeah,
great.
come on,
no.
You can put your hand on the thing.
It won't pick it up. All right, so let's clean this up a little bit so it's a little more clear. So not that it looks ugly, but let's just it's hard to read. Let's just say that. Okay. The work is good though. The work was really good.
That's how he does it. Everybody pay attention.
Okay. Wow.
Okay. So one other thing, it always amazes me when you have graph paper, guys. Use the lines that are given to you. Okay, so right there, I'm just that good, dude. Okay, and let's graph our. We are going to right now. Now we're gonna find our points. We did the easy stuff. Now let's find our points. Okay, so according to Jason, where's our other point gonna be? He's gonna go. Let's use Jason's method. He went up one and to the right. How much? And up and to the left too. So we should have that point there, yeah? That should be a point. What coordinate is that, guys? This is 1 comma negative 1, right? And negative 3 comma what? Comma negative 1, right? So let's just double check. Make sure that this does work. So how do I check it? It would be f of what? F of 1, right? Is equal to 1/2 1 plus 1 squared minus 2. 1 plus 1 is what, guys? So this is 1/2 2 squared minus 2. 2 squared is 4. So it's going to be 1/2 times 4. Whenever you multiply by a fraction like 1/2, it's really dividing by what? By 2. So this is 1/2 times 4, which is 2. And 2 minus 2 is what? 2 minus 2 is 0. Did it work? Didn't quite work, did it?
No, it goes up half. No. Yeah, doesn't go up by a half. It's a half.
I get what you're saying. So you weren't using that as a slope then? Okay, so just be careful when you use it that way. Okay, so it does work, but I think you weren't treating it as a slope. And that's what I thought you were doing. I thought you were treating it as a slope. Okay, so the point is going to be what? 1 comma what? Huh? Well, 2 minus 2 is what? So 1 comma 0. So let me redraw this. Okay, so tomorrow I'll show you why this didn't work right now. Okay, but for now, instead of using that, use your points. Use your points for now. Okay, I will get the shortcuts. You know, guys. You know I don't mind showing you guys the shortcuts. Okay, but let's use the long way first. That way we're comfortable with this, and then once we know the long way, then I'll give you guys the shortcuts. Sound good? Okay. This is 1 comma 0. This is negative 3 comma 0. What else do we have? We need 5 points. You're going to need 5 points on your homework. What's another point that I can use? What's another easy point? What is it? Right here. So, sorry, my bad. This point is 1 comma 0. How far is that away from my axis of symmetry? It's 2, right? Yeah, that makes sense? Yeah. So by finding 1 comma 0, I also found negative 3 comma 0. Okay. Exactly. So what's a closer point that I can use? 0, right? So I can use f of 0. 0 plus 1, that's 1. 1 squared is 1. 1/2 times 1 is 1/2. And 1/2 minus 2 is what, guys? 1 and 1/2, right? So this point, even though I didn't draw it very accurately, it will be 0 and negative 1.5. That's the point you got, right? So,
That's the point I got, right? That's not.
yeah, I get what you're saying. It's just the way I treated it is as a slope. You're treating it as something different, which is okay. Yeah. And what point would this be? So we found the point 0 comma negative 1.5, but we also found what? Negative 2 and negative 1.5. Very good, guys. Are we getting the hang of this? So we can start the homework?
Yeah.
Okay. So check it out. If